Good morning and welcome to week 3 data visualization and business intelligence. So we will cover those two topics, and I've got quite a few tools and examples to show. So, all right. So this week we will talk about, um, yeah, cut and paste. We will talk about the weekly objectives from the content folder, which I try to cover. Even though they're not necessarily part of the syllabus, it's more detailed in the syllabus. So it's basically data viz and business and BI, which are two very, very, very common things out there. So your weekly objectives are to describe, how data visualization helps in predictive modeling. Well, I can tell you right that's just looking at a regression line, looking at a line of correlation, and you can visually see that if X increases, Y is either going to increase or decrease. But it gets so much more complicated than that you can't necessarily count on a visualization. So anyway, yeah, explaining data visualization. Yeah, we'll get into that a little bit more and why it's so powerful. Um, uh, I'll give you a brief description of business intelligence, and I've got Power BI, uh, Microsoft's business intelligence solution pulled up. So we'll talk about that a little bit. And different types of analytic models. I mean, there's just the too broad, too broad. You've got regression models, logistic, linear, exponential growth, and then you've got machine learning algorithms, uh, different types of clustering algorithms. And it's just, yeah, come on. These classes are so compressed. So I'm going to give you some food for thought for the two assignments this week, and we'll focus on doing well in the assignments. Um, and then um, we will talk a little bit about big data within business intelligence, because it does sort of perturb things a little bit. Okay, so our primary objective, and I hope this is clear. If it's not, if I'm not being clear, please shoot me an email. But your primary objective with this week's discussion of data visualization and business intelligence is to think about them like a researcher, not don't think about them like a BI developer, like, I do Power BI or Tableau reports, and getting better at Tableau. Don't think about the coursework like that, because that's not what it's intended for. It's just intended to set the scene for you to think about how you would conduct research into data visualization. And there's lots of it out there. How does the human mind perceive things? What visualizations are more effective than others for certain types of data? What are accessibility issues for people that are colorblind? That sort of research has been done. So think about all of these topics like you would if you were the person actually conducting research, collecting data, and reporting the results of that data. Don't think about it like what you're doing at work, or you'll get too much of a practitioner mindset and not enough of a researcher mindset, as I was taught in my doctoral program. Okay, so there's your primary objective. Never, 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 never lose sight of that um, uh, as you're going through your PhD IT program. Okay, so data visualization, what is it? Well, come on, guys. We all know what this is. This is turning numbers into uh, pictures, representations that the human brain can make a quicker recognition of and make quicker decisions. And I haven't gotten it fully expunged from the program. I got it out of the content, but there's still a link to an article out there that I suggest you can read it critically, but it's garbage. The allotting visualization by Python and R. Um, in the there's so much article spinning in that article, and I've emailed the authors to ask them what were they thinking, and I never got a reply. Um, but yeah, they say data visualization techniques are authenticated scientifically as 1,000 times reliable rather than textual representation, which is what an article spinner would say to a picture is worth 1,000 words. So there you go. Um, and that idiom, that cliche, is true. A picture is worth 1,000 words. And in sometimes in data visualization, to me, it's everything. You would never, your brain would never make sense of the numbers. And I won't go into um, all the basic types. If you've ever had an introductory Excel charting course, if you haven't, you should probably do that. But if you have, then their chart, like pie charts are frowned upon, but they're pretty good at showing uh, relative um, size, relative numbers, like over half of something. That's a good pie chart. Then bar charts and line charts and box plots and all of those basic visualizations um, uh, depict the data better than your brain can. Um, but even like even a map is a visualization. I mean, it's got x y data, latitude, longitude, but then there's you can tell the population of a city by the size of the font, of the city name, those sorts of things. You can layer data on a map like topographical data or satellite photos or shading like a state park, different colors. A lake is blue, the land is normally white, that sort of thing. So there's all kinds of data represented in maps. But then there's even you're getting into these more advanced forms of visualization that are experimental, like virtual reality and augmented reality, where you present someone walking around with goggles, with data to interact with. You've seen it where they're sliding things around, touchscreen, Tom Cruise in a Minority Report, using like VR gloves to interact with the data physically, kind of like you do now with your mouse. I mean, you it's two-dimensional, but you're interacting with data anytime you click on something and it explodes. So yeah, interactive. It's getting there. Now, two people that you will see their name associated with data visualization. One is a old German psychiatrist that came up with the Gestalt principles. You might have heard of it. I'll pop over there in just a sec. And then a more modern person, I'm pretty sure he's still alive, Edward Tuft. I subscribed to an Edward Tuft video course that included his 5 books. He just talks philosophically about what you're doing um, with data visualization, and then you'll see. I posted a YouTube video in the classroom from a Dr. Rosling. I'm pretty sure Hans Rosling. Yeah, Dr. Hans Rosling, and he does a really good job of adding the storytelling side of data visualization and showing um, the effectiveness of motion in data visualization. As things move in a certain direction, it's much more effective than these snapshots you get with changing charts. So I thought that was very interesting. There's a lot of tools out there in this space. At the beginning of the classroom, um, they talk about um, Tableau, of course, which is owned by Salesforce. Splunk is another one. I thought I had seen Splunk being used in cybersecurity, but Alteryx, Click, Domo. I work with a aircrew training company that uses Domo as um, their primary, BI platform. Dundas BI, I've heard of. Google Data Studio comes with your Google account. I've monkeyed with Google Data Studio. It's not as um, user friendly, and there's not a lot of documentation on it. There's not much in the way of tutorials. There's volumes on Microsoft Power BI and Tableau desktop, but not so much on Google Data Studio. And then they list Einstein and Burst. This is all in your week 3 content folder. So anyway, yeah, lots of tools, but they don't mention Microsoft Power BI, which arguably is pretty huge out there. So anyway, but yeah, I wanted to go back, talk a little bit about Gestalt. So if I stop sharing that and I share, and you guys can go out and find this stuff. This is a presentation I did for another class. It's German psychology, meaning the form, and it's a way of studying, and you'll see academic papers out there. If you go on Google Scholar, you'll see Gestalt principles being used to see which was more effective in a given scenario for a given type person, population, those sorts of things. And some of you might have had a detailed course on this, so I apologize if this is um, repeat, but there's the principle of proximity, the principle of similarity, connectedness, common region, common fate, continuity, closure, figure ground. That's the majority of them. Every once in a while you'll see another one listed, but yeah, proximity is just that things together generally are thought because they're in the same space in your display, they are thought to be similar. So we kind of see how there's kind of two groups here. There's sort of a southwest group, and then there's a bit of a break, and then you got this northeastern cluster, which is another machine learning algorithm. We can use cluster analysis. So these are yeah, similarity, the dark green. They're all the same shape, right? So color groups the similarity, makes them similar. Okay. See the similarity can confuse the viewer if things are too similar. Like the slices on the left are kind of in the same font direction, and if you you can't tell that pink and yellow are related because they're not similar. But on the right hand pie, the light blue and the dark blue are maybe data from males, maybe below 18 and above 18. And the data on the right could be maybe females, below 18 and above 18. So if by making the similar wedges a similar shade, you have the Gestalt principle of similarity. So yeah, this is not anything you can't learn more about on YouTube or whatnot. Connectedness, if you actually draw a line, it makes it more, it makes data points appear to be more from the same group. Drawing a circle around, of course, if you if you're uh, um, in this business of data visualization, freehand drawing a circle is often a great way to draw attention to something, or drawing an outline around a pie chart, like uh, you're talking about. Oh, and I wanted to show you. Oh, this is Dr. Rosling's talk, Common Fate, up, which is showing data objects moving together along the same trend or for the same causal factors. So when you're watching Dr. Roslin, it's short, it's like 6, 7 minutes, maybe, not even that. When you're watching that video in the content area, remember the Gestalt principle of common fate and uh, continuity. We look at objects um, that are aligned with each other as being in a group. And there you go. And yeah, closure. Your brain automatically finds the peacock head, even though all this NBC logo on the left here, the peacock logo, all that is, think about it. It's a bunch of whatever you call that shape, teardrops with one little notch taken out. And all of a sudden it becomes a multicolored peacock. Yeah. And this IBM logo, or it's just a series of white dashes in the blue background, but your mind automatically closes it. This one fund I thought was pretty interesting example. There's a one and an F, even though really you don't. There's no F there. It's a thing that looks kind of like a one pointing to the left, and then two little quadrilaterals over on the right. But because your mind automatically fills that in, you visualize that as an F. So, yeah, and then the principle of figured ground. You've all seen this one, right? Um, the depending on what you accent as the figure or the background, the ground, you see a vase or you see two opposing faces. And then this one on the right is really famous. Um, do you see a young woman uh, or an old woman? And depending on if you've seen this puzzle before, you've got the young woman, right, with a hat on and the feathers coming up from the hat, and then what looks like a scarf trailing off the back, and she's looking to the left, and you're kind of looking at her left ear and her chin line there, and maybe a uh, the line is her neck. She's wearing some sort of large fur coat. Or you see an old woman, and what's the young woman's chin line is the old woman's nose, and what was the young woman's left ear is the old woman's left eye, and the necklace becomes the old woman's uh, mouth. So yeah, depending on how you look at that figure and ground, can change your representation or your perception of it. So fascinating, I think. So one of the reasons, let me stop sharing that and share my browser. I wanted to show you something you may not have seen. It's a pretty good example of why we visualize, and it's in Guess I'll share my screen. It's in Python. One of our assignments this week is Python. So screen sharing now, you're looking at, it's called Jupyter Notebook. It's getting to be in the world of analysis and data science, getting to be something you really cannot get away from. So if you're unfamiliar with a Jupyter notebook, I suggest you look into it. They're very simple. It's just a web rendering of a Python interpreter. The Python code and documentation cells. For example, this is a Jupyter notebook. This part that I'm highlighting right now is a code cell. And then down here, you've got your output. So in Python and R, you've got these libraries that are just phenomenal, just unbelievably powerful. And one that's used a lot in Python is called Seaborn, and the underlying visualization library that it relies on is called matplotlib. And I'm not an R guy at all, so but I'm pretty sure that um, there's a similar library in R. Anyway, so yeah, importing is just bringing in a code library, and there's a preloaded data set out there. It's not just in Python or in this Seaborn library. It's really famous. It's called the Anscombe dataset. I want to say this was put out there in the like the 70s, where you've got it's basically four sets of XY observations, and as you go down them, it it they look pretty. It's hard. I mean, you can't really tell. You've got data set 1, 2, 3, and 4 in Roman numerals there, so that's pretty easy. But look at these X's and Y's. It's kind of hard to make any real rhyme or reason out of them looking at the numbers, right? And that's the whole point of data visualization is it takes this ridiculous slew of numbers and turns it into a picture that your brain can understand. So the cool thing about the Anscombe data set is that each data set, even though looking at them, they look different, right? I mean, they are different, but they each have the same basic descriptive statistics. They've got the same mean, median, and mode. And yeah, don't worry about all this kind of stuff here. So in Python, we're creating individual data sets, and then we if you plot them in one way, that doesn't necessarily do anything for you. So just because you can plot a visualization doesn't mean you should. You do a scatter diagram, starts to make a little more sense. But the cool thing that I wanted to show you was the description, the descriptive statistics. So in that previous Python code, I created four individual data frames, are what they're called in Python pandas library, or in R. A data frame is just a table, really. If you check it out, they each have, I'm sorry, 11 observations, but the mean for each data set is 9. Check that out. Same standard deviation, same min, max. So it's the same data, really. If you, I mean, you would think with the descriptive statistics, and that's why descriptive statistics help, and they're important. But when you look at these four data sets graphed, because they're all XY, so they all use the same, scatter plot. It really tells the tale when you plot each one, and this is just some Python code to go through and set up a plot for each Anscombe data set. And if you if you just Google Anscombe data, you'll see this represented out there all over the place. You know what I mean? It's not uncommon at all. But if you look at the data set 1, 2, 3, and 4, even though they had the same descriptive statistics, the visualization makes the difference in the data sets just jump off the page at you. Like, for example, data set 3, um, that's a perfect XY correlation, except for this outlier, which skews the data. And data set 4, look at, they're all this exact same X value, except for this outlier, which is powerful enough to skew your descriptive statistics to being the same as the other three. So pretty fascinating, I think. That's just my quickest, easiest way to show why we visualize. We don't just run statistics on data. There you go. So if you want to learn more about Seaborn, there is a huge amount of graphs you can draw with Seaborn. I will show you a couple here. This is a tutorial on Seaborn. If you are a Python developer and you're or a Python, or you're learning Python, and you've used Seaborn but you don't have a real thorough run through, I would suggest going out on GitHub and finding the Seaborn tutorial, and the one posted by Claire513 is really good. But they're all Jupyter notebooks. These IPYNB files are all individual Jupyter notebooks, like this one. And it uses some built-in data sets, so you can goof around with these visualizations using test data. That's really handy. So anyway, there's just these different. This is all Seaborn. But like I said, it relies on Matplotlib. It extends Matplotlib and makes it easier and prettier. And so you need Matplotlib, and you need to know pandas. Pandas is data frames are built into R. It seems like pandas is a library that lets you deal with tabular data, like we see here. This is a data frame: ID, name, date. So once you have it in a data frame, it's a lot like working with Excel or anything else. It's pretty straightforward. And Pandas has all kinds of built-in stuff for you can run descriptive statistics on a column, or you can delete a column or add a column, or do any of the kind of data wrangling stuff like you would do with Excel. So anyway, that's Seaborn. But to me, if you're going to get into Python, you've never seen it, do a Python crash course. There's any number of them out there. But then learning pandas and NumPy and Matplotlib and Seaborn, the analytical libraries is where it really starts turning into a pretty cool tool. And you might be able to perform and publish your dissertation research using a Jupyter notebook. That's the one of the coolest things. As opposed to working in an IDE, you can document using these markdown cells. So if I double click on this markdown cell, you'll see it's kind of like HTML, where we start to see some tags and whatnot. But if I run that cell, it turns it back into the pretty stuff. So yeah, markdown cells are a way to document your code as you walk through it. And you'll see, beg your pardon, you'll see like on Kaggle, just, oodles of data science projects that are published as Jupyter notebooks. So I highly suggest you look into those. So let's see. I think I'm done with that. So I say file, close and halt. When you open a Jupyter notebook, it opens a Python kernel. So you have to shut down each one. And then, yeah, GitHub. There's so many tutorials out on GitHub. It's just incredible. So back to our data visualization. So yeah, Power BI and Tableau to me have the most market share training available, those sorts of things. But it changes so fast, it's hard to keep up. So beyond basic charts, there's every time now that I've been in this world and learning it and teaching it and talking about it and discussing it, I always look at the way charts are presented to me, and and it bugs the heck out of my wife. But I'll say something like, "That's deceiving because the scale isn't zero based or something." Yeah. There's a lot of ways to confuse issues. Um, One thing I remember back in 2016 was a complaint from a lot of my friends who were Trump voters that only a limited number of counties um, elected or voted for Hillary for the popular vote or whatever. And if you look at a map, red is Trump, blue was Hillary, and if you look at a map, it looks like the overwhelming majority of the country voted for Donald Trump because there's so much more red than there is blue. But you know if you look at these graphics, this is absolutely the same as a population density diagram. So more people live in the blue. So yeah, there's misleading uh, um, misleading visualizations out there if you're not careful. And then there's other kinds of visualizations way beyond. I mean, there's just hundreds of ways to depict things out there. I like that. This is a heat map that shows like a web designer what is drawing the human eye, and this goes into like I said our primary objective for the week is thinking about visualization like a researcher. Um, how would you tell what about a visualization was drawing the human eye and how long they looked at it? You could even do like a quiz using a camera. Looking at the human eye can tell what the eye is focused on. You could even do like a how long did somebody have to look at a visualization before they were able to answer a question about it? And they look at the visualization, and then the eye transfers over to the A, B, C, D, or wherever they have to choose. So you can correlate how long they looked at uh, um, the visualization, the graph, the chart, the web page, whatever. Um, you can correlate how long they looked at something with their likelihood of getting the right answer. So there's just any number of ways to research this stuff. Um, Pretty cool. And so I just went out looking for just different visualizations to share. So here's another one. We see the the color bands are just um, east to west. There's no it's just geography. You have Asia in green, basically that longitudinal region, and then we shift over into yellow for Europe and West Africa, and North and South America are primarily red. But um, the there's a lot of information packed into this map, even though we don't have city names, we don't have country names, and if you notice, you don't even have continental borders. Look at that. When you first look at this, you instantly recognize this visualization. You visualize planet Earth, but there are no geographic lines drawn on this. You see that? These are all just the circles are an airport. The size of the circle represents the number of passenger um, embarkations and debarkations. So the busier airports are the bigger circles, and you can see like in the middle of Europe there, that's probably Frankfurt, and you can see JFK and Chicago, Atlanta. Look at that giant circle in the southeastern United States. That's Atlanta. Big circle in the central South United States. That's Dallas. And then you've got Denver, Salt Lake, Vegas, LA. You can see these Buenos Aires, South America, Cape Town, South Africa. I don't know if that's Cape Town or Pretoria. Anyway, you almost can see the shape of Africa from the coastal. All the airports are on the coast, so it almost outlines the shape like that. Pretty interesting. But yeah, if you look at this graphic, there are no national boundaries, but you can sure see the continents. Anyway, so that's pretty cool. And then here's one that you'll see examined a lot. Our buddy Edward Tuft loves this. This is a graphic, a visualization of Napoleon's Grand Army, l'Armée de Grand, marching to its eventual destruction in Russia in 1812, 1813. So it starts out um, in a river way back in Central Europe, and the thickness of we'll call it pink. The thickness of the pink band is Le Grand Army. I want to say 400,000 people. Like I said, there's all kinds of cool videos and stuff on this. And then as you go from left to right in pink, you're going forward in time and eastward in physical direction. And there's a couple of little branch offs you can see here. They had, I think, 28,000 people basically uh, came to the end of their enlistment and left. And then you've got this leg shooting off and then rejoining. That was like a little side campaign, but you can see the size of the army dwindling. And every time they did a river crossing, they lost more and more and more and more people. And then on the right side of the screen, you can see of the 400,000 people, soldiers that left. I don't remember if that was the Rhine or the Meuse. Anyway, that left that river in Central Europe. By the time they got all the way into the outskirts of Moscow, they never really did enter Moscow. They never really did fight. Um, Old man winter set in, the Russian winter, and and they turned around and left. So the pink visualizes the advance, and then the black thicker line symbolizes the retreat. And then you see them like every time they made camp and retreated, they get smaller and smaller and smaller and smaller and smaller until La Grande Armée gets back to where it started. that same river in Central Europe. And I think it's 10,000 are left of the 400,000. So 1/40th, which I think that makes sense because these are to scale. The size of the lines are to scale. So yeah, it's a pretty fascinating way to depict, when and where and how large the army was, and the different geographic um, features that impacted the size of the army. Yeah, I thought that's pretty cool. So anyway, yeah, data visualization. We need to do what is business intelligence? Um, uh, BI is generally what's going on in your business intelligence. So it's using data to see what's going on. And generally, as you'll see at the beginning of the content folder, generally it's descriptive. It's what went on last month, what went on last quarter, last year. Um, but it doesn't really necessarily delve into predictive analytics, which is, you know, using either simple mathematical linear regression. Might be able to say if we increased advertising spending by 10%, we'll see an 18% increase in revenue. You can project those things and do prescriptive analytics or predictive analytics. But BI is really more about these kind of like these dashboards, at least classically right now as the way it's defined. Now, this tool on your screen right now is Power BI Desktop. And this is available as a free download um, from Microsoft. And this visualization, this dashboard that you're looking at, is um, a a demonstration, a sample, human resources oriented Power BI visualization. So a lot of what's going on in Power BI um, looks like Excel. See your over here in your fields. These are all spreadsheets. I'm having a little bit of trouble connecting to this data. This particular example connects apparently to a MySQL or a SQL Server database in the cloud, and my Microsoft account is not behaving. So I can't dive into the data. But each of these could be under fields, could be related spreadsheets that you've queried out of or it could be an actual query from an RDBMS. And then these different visualizations the icons should look familiar because they're the same things basically that are available in Excel with a little bit more. Um, so you've got these are all different objects. So this is a graph here. Um, and then there's a pie chart. There's another pie chart. Each one of them can be tailored. You associate the fields. If I click on that, um, underneath the visualization here, um, you can adjust what fields you're looking at, just like you would an Excel chart. Each one of those is like an individual Excel chart, but you have this canvas that you can put multiple charts on, kind of like you would an Excel tab. It's not a whole lot different. And I think that's on purpose because you've got Excel users, and you know how publishing data with Excel, people are trying to get away from that. People are trying to get away from reporting in Excel because something like this is a little more. It's got a little more real estate. It's there's connectors built in. It's kind of next level as far as your data access. And the screen real estate is different. You don't have the worksheet cells cluttering things up, So you can have tabs for each one. And then you can have different kinds of charts, or you can have like this is a text box. New hires is a text box. So there's basically three parts of Power BI. You've got the Power Query Editor, which is where you set up your, they call it a query. They're really worksheets or tables. But then you get into, you can model the data, which looks a lot like an entity relationship diagram in a database. So once you get the your data tables set up, which is this is the um, these are all the tables. Once you get all of them set up in your Power BI report, then you can come over to relationships, and this is how you, just like RDBMS and SQL, you've got primary keys and foreign keys. This is how you do that, and you can drag and drop, and this will come in automatically if you have relational data. Power BI is smart enough to know that, and if it's a query coming from a database, it sort of pulls that stuff over. So you've got those three. You've got your data, your relationships, and then you've got your actual your report or your desktop or your um, dashboards. So these are each one of these would be considered a dashboard. So that's BI. That's business intelligence, is using business data to go, oh, what's trending downward? Age 50, bad hires. Age 50 are going down. That's right, because people over 50 are good hires. There you go. So anyway, yeah, these are all human resources oriented data points and visualizations. So that's Power BI. Tableau is very similar. I'm having trouble getting into Tableau. I've got a license for it, but it's giving me trouble. But again, if you're interested in any of this, to learn it to the point where you can study it, remember our primary objective. Think about visualization like a researcher. How would you add to the body of knowledge as to the usefulness, effectiveness, harm, badness of data visualization in all of its incarnations? And then analytic models. That's a little too complex. But then big data models. Now that's an ongoing challenge, because you've got now a fast flowing river of semi-structured data that's now being presented to business intelligence developers that are used to doing dashboards like I showed you. So what they've got to do is automate the receipt, the transformation, and the consumption of that data in a BI dashboard. And a lot of these things can be interactive. These can change kind of in real time, depending on the nature of your enterprise, the nature of your data, the tool that you use. I've seen operations centers that they're not using a desktop application like Power BI. They're using something that changes in real time. Like I was in the operations center of a utility cooperative that is responsible for bringing up or scaling back power plants throughout the Midwestern United States based on demand. So you had these displays going on showing the current temperature in different places and changing, and whether it's increasing or decreasing. So you got an arrow next to it going up, pointing up or down. And then you had the number of kilowatt hours next to some place compared to average kilowatt hours. And is that increasing? Is that decreasing? Those sorts of things. And it would show, predictive like electrical demand loads over the next 6 hours or whatever, based on current. So yeah, there's a whole great big giant universe in data visualization out there. Yeah, trying to cover BI and that in a in an hour-long lecture in an 8-week course, forget about it. But at least it gets you thinking of this. If nothing else, I want you thinking of your dissertation and what's coming up. Because let me go back to our website, our classroom, and here we got fundamental issues why dissertations fail. Make sure you are watching these, guys. And this isn't about getting all the way to the end, you presenting your dissertation, and they say, sorry, you fail. That's not what it's about. It's really more of a why dissertations fail to get going and get moving and get executed. If you get all the way to the end, then everybody's been saying good, 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 you'll be good. But the problem is too many folks don't pay attention to these sessions, like choosing a dissertation topic. Here, we talked about this a little bit in the first week. Choosing your dissertation topic, a topic area versus a research question. They're different, and you need to dig in on that, guys. It's not just about the coursework. It's about becoming a researcher. Okay, so some good stuff there. Yeah, these are the articles I suggested. I hope you like them. So let's get to the assignments, and I will stop yapping. Okay, your research paper. Okay, please listen. If you're on YouTube watching at double speed, please listen to me. Every semester, somebody gets a 0 on this paper because they go out to Course Hero and they find a paper that talks about Fortune 1000 as if Fortune 1000 is a company. Listen, Fortune 1000 is not a company. Fortune 1000 is the list published by Forbes magazine. No, Fortune. I'm sorry, Fortune magazine. Just like the Fortune 500, right? The Fortune 500 list of companies. Well, the Fortune 1000 is the same, and the Fortune 100 is it's just the top 1,000 companies in size and market capital or whatever in the country. It's the big companies. Okay, so you need to go out and find an example like the one I presented of I think it's CJ Logistics, where some company integrated big data into an existing business intelligence effort. So it's integrating big data with traditional BI. And traditional BI is much more structured, very structured. And it's the the data. Traditional BI is the data coming out of your sales data, and your HR systems and your ERP systems as far as units produced and how many parts were consumed out of your bench stock and those sort of things. Very structured data. But then you start infusing big data into that BI, and now you can start getting things like social media sentiment, you know, uh, infused with maybe your marketing spending, and your sales numbers. So if people are blowing up about a video, or you're seeing bad comments in social media and in an unstructured way, and then you start to see sales dropping off in your structured data. Those are the kinds of integrations we're talking about. So in your paper, find a specific Fortune 1000 company. That will be a name of a company like Walmart, Amazon, Sears, J.C. Penney, whatever. It'll be the name of a company. If you turn in a paper that writes about Fortune 1000 as if that's the name of a company, it's going to be a zero because I've seen it. It's out there. It's out there on Course Hero. I don't need to see it again. Okay, so that's your research paper. Usual requirements. But you're talking about integrating big data with BI. What they're doing right, what they're doing wrong, how they can improve. So it's just a real quick analysis. And section headings always help, guys. What they're doing right, what they are doing wrong. Those make great section headings. Okay, if you're reading the paper, reading the instructions critically. Okay, and now your other assignment, your discussion, is a comparison and contrast of R and Python. And you will notice there are some requirements. Identify the pros and cons of each. They're both open source. If you if you can please cite a source that that really gets into, no kidding, I know what they are. I'm not going to spoon feed you. I know what I think the strengths and weaknesses of each are, particularly Python. But check it out, and identify some pros and cons. And then you're all computer science folks, so provide a code snippet of each doing the same thing. What's an if then else block look like in R or Python? And you only need to do one. You only need to do one example of what code looks like with each. What's a for loop look like in each of those languages? What's an assignment statement look like in each of those languages? Maybe drawing the same graph. What's the line of code that draws a scatter plot in each one? So yeah, an experience. If you are experienced in using either one of these languages, professional or personal, like for me, I've helped people at work using Python, but I'm not a Python developer. I learned it so I could teach it, because it's now the new basic programming language that they teach in grammar school. So you got to learn it. By the way, I'm a mediocre beginner Python programmer. And I'm not going to get involved in R. So there you go. And if you have no experience with either language, just give us some idea of how you might use them, your attitude towards them. Your attitude might be, I ain't learning either one, and that's okay for that number 5. You're okay to say that. This is a class discussion, remember? Okay, so those are your 2 assignments this week. I'll reiterate. I graded the week 1 discussion. I want to add a few points. lectures, in-class discussion, aren't doing real well, and starting in week 2, I've already seen it. Good post. I want to add a few points. That's going to be a 0. I mean, you might as well not even bother with it. I want real discussion, actual discussion. Okay. And that is that for week 3.